Hello, this recording is about modularizing code. Modularizing code is breaking the code into modules or pieces. Modularizing code makes the code easy to maintain and debug and enables the code to be reused. Some functions that are developed for one program can be reused in another program. Here we have two examples. Two programs that use functions, modules, to reduce complexity. The first one is a program that finds the greatest common divisor of two numbers. The greatest common divisor of two integers is the largest positive integer that divides each of the two integers. Let's run it. It asks for the first integer, give it 12, the second integer, give it 8, and its output is the greatest common divisor for 12 and 8 is 4. Let's check its main code. This program has a main function. The main function gets the two integers and it calls the GCD function. The GCD function, the two passed parameters are n1 and n2. GCD returns an integer, and this integer returns an integer which is GCD, and the returned integer is output to the screen. About the algorithm used to find the GCD, I'll explain it in a next video. For the second program prints prime numbers. A prime number is a natural number greater than 1 that cannot be formed by multiplying two smaller natural numbers. Let's run it. This program gives this output. First, it says the first 50 prime numbers are, and gives 50 prime numbers, 2, 3, 5, 7, 11, 13, organized in 5 rows. Each row has 10 prime numbers. Notice that this table is well organized. Each number is in a cell of 4 characters. Let's check the code, the main code of this program. Its code is on 3 slides. The first slide has a function called isPrime. It accepts one integer and returns a Boolean value. It returns false if the number is not a prime number, and true if the number is a prime number. This function is called from another function called print prime numbers. This function prints the 50 prime numbers. It accepts an integer number of primes and does not return anything. This function is called from the main function. The main function simply prints the first 50 prime numbers are. It calls the print prime numbers function with an argument of 50, and when this function is called, it prints the first 50 prime numbers in a table. It starts with initializing count to 0, and the prime number cannot be 1, so it starts with number equals 2. Here we have a while loop that is executed as long as the counter is less than 50. For each number, it checks this number using the isPrime function. If the number is not prime, it does not print it. If the number is prime, it increments the counter, checks whether it has whether the count is divisible by 10 or not. If it is, then the number is printed in a 4-character cell, and it goes to the next line. Otherwise, the number is printed in this 4-character cell. After checking the number is incremented, and as I said, the this loop continues to iterate as long as the counter is less than 50. About the algorithm used to check whether the number is a prime or not, I'll describe it. I describe its operation in the next video. So this program has 3 functions: isPrime, which is called from print prime numbers, which is called from the main function. This is the end of this recording.